Good morning. Still morning, right? It's a pleasure being with both of you today and with everyone here in the audience. As we transition to a more electrified future, the stability of our power grids is paramount. And so today's session will dive into the technological advancements and policy measures needed to keep our power grids resilient and our electricity consistent. So to address the challenges of integration and the solutions, we're going to, of course, turn to our esteemed panelists. And the first question I'd like to address to both of you, but in general, by all means, feel free to chime in if you have something to add to the other panelists' questions. So power grids are facing growing pressures to adapt. How do you see governments and the private sector working together to ensure grid stability, especially while having to meet decarbonization targets? Juan, let's start with you.
Okay, thank you. Thank you very much. Good morning to all. Probably I'll answer that question with three examples of three different scenarios in three different countries. The first country is Colombia, off-grid technologies. You have solar, batteries, and a diesel generator doing a kind of model. Then you have DR, which is a country with 1 gigawatt in solar and then having troubles with the grid because there is no policy innovation. And then you have the Red Sea project from Saudi, where they are doing all these integrations. So the responses are very similar, but the equation of how we solve the problem is mainly based on how we manage that energy. And the specific case is in an off-grid community with diesel generators, you just ramp up power, and then you just burn diesel, and that's the best solution. Then in DR, you can do a mix, but you still have to rely in electronics to solve these instability problems you're finding in the whole grid being unbalanced because of the renewables. And then there are these new projects where they do huge off-grid communities with microgrids, and they're trying to solve the whole problem from zero. So there are three different cases with three different budgets solving exactly the same problem. How we are able to bring a frequency or an stability to a grid that is being suffering from the inclusion of the renewables, mainly.
Doctor, what's your take coming from the more technical side? What would you say, and how should governments and the private sector collaborate? What is the best case scenario?
I think this is at the core of things. The investments needed to secure an energy transition is so high that it will not be only governments or only private sector to do it. It has to go together. We're talking, I think we saw numbers earlier by His Excellency Attayr, of trillions of dollars of investment needed over the coming decade or two in order to really achieve the targets that have been set internationally. Governments and private sector have to work together, and they are, because it's not just a great cause to work for, but it's also a great business opportunity to transform society into a more green supply of energy. And I think if we look at UAE specifically, the leadership is very much advocating the interconnection between private sector and government. And we see it in the projects that are being launched. We see it in the ways the government is entertaining private companies to really design and build projects that open up the market, not just UAE, but across the Middle East, to building a whole new economy that relies on green electricity and green fuel.
But then, of course, the developed world and strong economies will have an advantage as far as it comes to integration. And then, as you mentioned, Juan, smaller islands will have a bigger challenge and could face possible blackouts.
I'll go to the same three cases. The first one, most of the investment is done by privates because it's the way of solving the problem, because somehow there is, in the underdeveloped countries, there is lack of, let's say, governmental investment. because of the budget. Then the second one is a mixed in between government collaboration with policymakers, which is very important, because at the end you're bringing technologies in and there is no policy for those technologies. So if you are not able to have policy for those technologies, you are not able to invest, and then if you're not able to invest, you might not be able to be willing to be there. And then the third one is a full governmental investment. So those three cases highlight like the differences between doing solving the same problem with three different budgets.
I see. Dr. Siemens is known for innovative grid solutions worldwide. So from your perspective, what are the most critical technical solutions that Siemens is bringing, and particularly here to the Middle East? Maybe you can give us a more local example.
Well, thanks. I mean, that question is prone to opening up all of the portfolio of Siemens. I'm very grateful for that, but I'm not going to do that. I'm just going to comment in general. It's a game that not just Siemens is playing, everybody has to participate. So this is whatever we offer to the markets is one element. There's other elements like the ones you represent. There's other elements that competitors represent. But ultimately, what is the most crucial technologies is everything starting from enabling green generation of power to transmitting and distributing that with also as green as technology as possible. In the substations, for example, when we talk about switch gears that used to be, or the common state is that they're using gases which are really not good for the environment. So the new generation that's now coming up and has been under implementation also in the UAE is SF6 free switchgear technology, which really has a huge impact on greenhouse emissions worldwide if you really roll that out at scale. But then it continues. It goes to how is the energy distributed to the end user? How is the end user engaged in the whole game of renewable energy generation? Because we need to understand the change that's currently happening is not just a fundamental change, it's actually a revolution in the industry. We have utility companies that have been supplying power to their consumers over the last 50 to 100 years, depending on where we are in the world, and they have relied on centralized generation where the power flows from the power generation to the consumers, and the power generation can follow the consumption patterns.
So how do you help them make that shift?
Well, the shift is that now we're seeing more renewables come in, so the generation patterns are not as predictable anymore. So in theory, where we need to get to at some point, we need to get to consumption following generation patterns. And that's basically flipping the entire thing around. And that then has implications on technology. It has implications on how we control the power flows. It has implications on how we engage with end customers. It has implications on the mindset and abilities of utility companies. So it has a lot of facets that we usually don't see in the media, because what we're usually confronted with is new generation projects. These are of utmost importance, but the complexity arises afterwards. How do we integrate these into the grids? How do we build out the grids so that this power can actually be used?
Well, and integration is the challenge. Juan, you're on the front lines of solar energy. What would you say is the biggest challenge for solar energy producers like yourself in this regard?
Well, the biggest challenge I'll say the renewable energy companies are facing around the world is that they are growing faster than the transmission lines. So at the end, there is no enough points of connection for that raw power that we are trying to bring to the system. So at the end,
Juan, if you allow me just to quantify that, what you were saying in a side note, the transmission lines are not following the buildup of renewables. And to quantify that, whatever was built over the last century, so the last 100 years, basically needs to be replicated in the next 10 years. So everything that all of our previous generations has done, our next generation has to do in one go.
Yeah, actually, that's something that is in somehow bringing a huge alarm, because the energy consumption probably doubles or triplicates in the next 20 years. So we're not able to generate enough energy from the renewables, either because we don't have transmission and because they have just their behavior. They are just from the sun and from the wind, so then you need other technologies. But probably the point is, coming back to your point about the advanced metering technologies, is energy is becoming very smart. We've been able, with, of course, mainly of the frontliners like Siemens, they are being somehow making the energy smarter every day, from the generation to the distribution. But the issue is that you also need to have smart consumers. And that means that it's not possible to triplicate the generation, and then we don't reduce 1/3 the consumption. It's like an unbalanced equation. So the only way of having this is installing advanced metering technology to avoid consumers demand more, and at the same time trying to have bigger generation and a diversified generation, and of course new technologies coming into the grid, so then we can somehow balance this huge consumption that is coming the next 30 years.
Juan, we're talking about grid integration. I really like the analogy that we spoke about earlier backstage, because it can sound very technical. So if we want to really simplify and explain why it's so important to integrate the power grid.
Well, it was an example it was like the grid forming technologies are like the suspension of your car. So if you're driving a Ferrari in the highway in Checkside Road, you can drive 160, no issues. Then if you go to mid-dune desert, you can know. Some guys can go in, and then some other guys can go up. So that's exactly what happens when you start integrating technologies without the proper, let's say, vehicle. So the grid forming technologies, what they do is they are like the shock absorbers of your car, so they are able to just leave you go smooth in the highway, and then when you go off-road, you can also go smooth. So that specific explanation of how you can, somehow, with technology, because it's very important, because this is like mainly digital. It's like if you were having like digital shock absorbers, allowing you to somehow understand the patterns of the road and being able to have a smooth ride.
So if we look at the grid as your car, it needs to be able to deal with any type of scenario,
Exactly.
Predictable or not.
Yes.
Thank you for that. And you mentioned...
Can we stay with that example for a second? Because I think it's a very nice one, nice analogy. I think that's the perspective you were outlining was from the car itself. Now, if you look at what a utility company needs to do, is basically they need to smoothen out the desert sand before the car actually gets there, so that it goes as smooth as you can. And in other terms, they dispatch the different sources of energy and storage and grid forming technologies when they need to kick in. And this, you can imagine, in the past was a matter of, well, a very simple optimization. There was a couple of large generation units, and you dispatched them according to the daily profile of demand that is more or less the same every day. Nowadays, while renewables are coming in, storage technologies are coming in, you have grid forming elements in the grid, you have EV chargers in the grid, you have heat pumps in the grid. Now that optimization is at a different scale of complexity. We're talking about millions of players in the grid, so millions of little dots that can come up in the sand to make the ride less smooth. And that's where technology really plays a key role. So tech, what I mean, so software, that was not so prominent in the past. And this is really where also part of the revolution is happening, that we're seeing that control room technology is simply not capable anymore of managing that complexity. So we need to go to the next level. Human interaction is not capable of managing that complexity anymore, because you need to react super fast. I mean, you imagine a wind park with solar park with 250 megawatts, and there's a cloud coming by. So suddenly, within seconds, you have a drop in generation capacity, where then technologies like yours need to kick in, perhaps, unless you mitigate it otherwise. So human capabilities are getting to the limits because of the amount of data and complexity that's there. So what we need to work towards is, same as in other industries, to automate that as much as we can, because we have digital technology that can help us there. But it's a bit also of letting go, right? Letting guidance by some anonymous technology take over something that was handled by humans over decades. And this is really an interesting game to see.
And you mentioned a solar park, and when we spoke earlier, when you see in the news, a new solar park is being built, we're all thinking, great, that's wonderful news. But from your end, you're also thinking about the challenges that brings forth. Take us through your thought process.
Well, it goes in the direction I mentioned. It touches every single aspect of the operations of a utility company. It starts from planning out grids. So in the past, you had you made a plan for your grids over, let's say, a couple of years, right? You forecasted different patterns of consumption, worst case, best case for summer and for winter, let's say, right? And you calculated them, and that's how you said, okay, I need to build out certain lines, I need to build out certain substations. Nowadays, you need to plan with thousands, hundreds of thousands of elements coming into the grid, and you still need to be able to provide an accurate forecast and an accurate build-out plan, and we're talking billions of investments, right? So you need to get that right. So that's where it changes, right? So instead of doing worst case, best case, summer, winter, you need to do time of day analyses across all kinds of contingencies that might occur from weather phenomena, from individual consumption patterns. It goes across operation, what I just meant, autonomizing operations so that if there's a shortfall somewhere, we can isolate the fault, we can restore the grid, we can send maintenance teams faster so that the incident goes away. It's about the skill set that individual operators, that
an entirely new skill set that's required.
Exactly, it's a complete switch over that also touches organizational structures within utility companies.
So Juan, you're coming from the renewable energy side. Sunco is a disruptor in the energy space. So what innovative approaches are you using to ensure that intermittent solar energy doesn't destabilize the grid?
Well, that's the rescue kit. So when you go to the sun, you get stuck, then you have the rescue kit. Mainly a rescue kit in renewables is trying to do integration, solar batteries, and grid-forming inverters, or started with grid-forming inverters, now grid-forming inverters, trying to in somehow keep that balance. So at the end, it's like you used to have the renewable guys in one side of the equation, just private investors just trying to connect to the highway. Then the government's owning the transmission lines and then just in somehow granting permits for those guys to connect. Now, you need to have something in between because at the end, there will be a smooth in somehow connection to the grid, allowing new technologies to be connected that might need to be done by private guys. In other ways, you are trying to build assets that are not mainly selling energy like the other ones. Probably they might be selling energy, but another 5, 6 revenue stream above them. Like it's like an arbitrage model. At the end, you're just trying to, in somehow, you are the rescue kit. So you need to charge for the rescue. So in that specific equation or case, we're working with a government in a Caribbean island where we are in somehow designing different rescue kits all around the grid because we already identified these guys that are going all the way in those moments and they get stuck. What means that they get stuck? That they were willing to supply 200, 300 megawatts of solar power, and suddenly there is a huge cloud coming into the country, and they need to start all the generation around just to keep up with the demand.
But you're talking about rescue kits. What does that include? Because when we spoke about energy storage, you said that that's too expensive usually and not a viable option.
If it is for rescue, I mean, if it is for that specific application, that would be the best way to do the investments. If you just do, like countries are doing that, they do just like solar parks with only batteries standalone, that could be a problem. The reason of that is because you're using the whole solar plant to load or to charge the batteries. And that's not cost efficient. The only way of doing those kind of rescue kits cost efficient if you do hybrid power. That means doing solar batteries and in somehow any kind of synchronous generation connected to them. There are many, and it depends on any country, of every country, of what kind of technology they use, but mainly it's doing hybrid power.
Now that we've touched upon innovation, Doctor, given the scale of electrification, where do you see the biggest bottlenecks? Is it technology? Is it regulation? Is it investment? And then what can be done to overcome them?
So I think investment definitely is one, and that was a big theme at COP last year. So let's say this has been addressed. Maybe not sufficiently, but it's on the radar. I think the biggest bottleneck is on the grid side. As Juan also mentioned, generation buildup is happening at a scale and pace that has never been seen. The actual challenge comes with following up on being able to transmit that power into the different areas of countries. And because it just takes time to build cables, to get permission, to get permits, to build substations, there's also a supply chain dimension to that, right? You can't supply all of world's copper resources into one country in 1 year, right? So that build out is really the bottleneck.
Infrastructure.
The infrastructure, yes. I mean, we're talking about, in the UAE, we're talking about at least doubling, perhaps tripling of consumption of electricity over the next 20 years. Because, I mean, we started with EV, but now the industry is following. I think the very ambitious sustainability targets of the country and the vision towards decarbonize until 2050 also includes heavy users like oil and gas industry. So once that kicks in and needs to be supplied with green energy, that's already probably a doubling of electricity consumption. So the grids need to follow, the interconnections need to follow, so that also following examples maybe in Europe where you actually speak of a copper plate because exchange of energy can happen seamlessly across countries. I think the GCC countries are working on that, but that needs to be accelerated as well. And in the meantime, I think because you're also asking how to overcome that challenge, it's not hopeless, right? I mean, there is technology to increase utilization of existing assets, and that's more on the digital technology side. On the software side, there are technologies that enable you to transport up to 20-30% more power through existing lines because you have sensors and you have forecasting algorithms and you have simulations that can tell you how far you can get close to the physical limit, while traditionally that's been done by just keeping a buffer, right? And we can use that buffer to already increase the capacities with the existing assets simply by relying on software.
So we have the technology, but there's the issue of cost, and cooperation is key. I see that we're almost running out of time, so I'd like to just give each of you time for final thoughts that you'd like the audience to take with you. Juan.
Well, probably the biggest challenge we're facing right now is we need governments to do policy in order to private investors bring in different technologies into the grid. The problem is the grid is mainly critical national infrastructure, which is very complex to be in. So they need to open specific connection points mainly in countries where energy is much needed. And that specific approach, I'm just going to highlight this island case because it's a case that is happening in the whole Caribbean islands. I've been seeing this case and it's ramping up because they are developing a lot. Now we are having an oil booming a scenario in the Caribbean, so all those islands are having a huge demand of energy, and they don't have enough, of course, transmission, not generation, and they do have the money to invest. So it needs to happen like a harmonized integration between the grid owners, that means the utilities of the world, needs to innovate in technologies that allow to bring more capacity into those grids, and at the end they're very similar, so they can innovate together. So probably my message is worldwide utilities should innovate in the bottleneck the rest of the technology are having. So we need these transmission companies to have smarter infrastructure for investors to be on them.
And the governments should be pushing for the regulation to back that.
Yeah, they own that.
Your final thoughts, Doctor?
I'd like to end with perhaps a call to action to the audience as well. I think if I had a wish of one thing to go out with is that really the grids is the key part that we need to look out for. So everybody in the room, if you have any touch points with any regulators, any government officials, any of your friends working for DIWA, EWEX, and the others, or maybe even employees in the room, show them your appreciation, because they are the ones that are actually going to decide through their actions whether we can continue being used to continuous power supply at all times of day or not. Right? So please support that cause, and if your career choice is currently under definition, then please join the industry. It's a cool place to be in at the moment.
And I feel like you're also hinting to say we should all really appreciate the fact that we do have continuous electricity, and it's not something to be taken for granted.
Exactly, exactly. We have been used to that, but that is under debate.
Well, thank you so much to both of you. Very insightful. We could have continued the conversation, but unfortunately we're out of time. So thank you for sharing your expertise with us today. Thank you.
Thank you. Thank you.
Thank you.